David Rohrbaugh, you want to be my person? And I'll, whoops, should be fine. Cool. Do you want to stand over here or like sit? Actually, sitting might be better if you sit like right here, yeah. Also might rotate your chair as opposed to walking around you. Might be easier. So you ready? Yep. Just let me know. Whenever you're ready, I'll start going.
Alright.
Okay. Well, welcome to the Idea to Product scanning training session. My name is Jim. First thing we're going to be going through is the Sense scanner, which is this guy here. This guy works in sort of the same way an Xbox Connect does. It uses two different cameras and gives sort of 3D locations based on what those two cameras are seeing. So it gives you color as well with your scan data, which will not be the case for the second scanner we go through, but the second scanner will have a much higher resolution. So for this first scanner, we've got my model here, David Rohrbaugh. And we're gonna go just for a bust scan. So with the Sense, it will ask you sort of what you wanna do. If you select object, it will give you 3 different sized objects to choose from. A downside is you sort of have to select one to go back and start over the process. But once we select person, it'll give me an option for either head or full body. So if I go head here, you'll notice that I'm starting to see some stuff on my screen here coordinating to what it is. But one thing you'll notice is it sort of starts cutting off around the edges here. And that's because it actually has a depth distance where you can go with the Sense before it stops registering data. And that just sort of goes hand in hand with the bust being just a small little area that you need to scan. So the Sense actually restricts the area that it can tell to sort of maximize scan quality. So to start off here, what I'm gonna do is make sure he is well in focus. You're gonna have to not move for the rest of this though. Okay, so that'll work. Once I hit the start, it'll give me a little countdown here, 3, 2, 1. So if you'll stay still for the rest of this. You'll notice it gives me an accurate representation of what it is seeing right now. The white areas are the data that it has not quite recorded yet. And right now it is going very slow. So right here, what you see, it says lost tracking. And so what that means is the scanner is not quite sure where it is. Basically, what I have to do right now is match up that as close as I can to the scan data I already had, which is not working great. Another thing that helps with the Sense scanning is if you have a lot of good lighting in a room, which we do not have in here, but we can still start again. So do you mind scooting a little closer to me? Mm-hmm. Cool, thank you. So, starting again. I don't know why it's not picking you up. Oh, there we go. That's a little better. 3, 2, 1. One of the things about scanning is sometimes things don't quite work out how you plan, and you have to start over multiple times. And it's just sort of part of the process here. So you see it lost tracking again. If I kind of match it up with his head, it'll come back and remember where it was. So basically, the longer I go, the more data it will collect, the more it'll sort of correct the stuff it already has. So if there's some weird outcroppings or something that are inaccurate and you go over them again, it will actually correct them. Well, software is going a little slow today, it's fine. If I go back to the front, we'll see what happens. Yeah, whatever. We're gonna go on for the sake of the training, save some time. So this is going to be an incomplete scan, but luckily there are some processes on here that will fix that. For all scanning programs, they usually take a lot of memory and a required decent graphics card. So you can see this is going pretty slow on here, and it's probably because we haven't restarted the computer in a while or it needs updates, one or the other. But you'll see here it gives us the scan data we already have. Did that just zoom in all the way? Where are we? There we are. So you'll see here we have our scan data, a little incomplete, but I'll show you some of the operations of the Sense program. So although we don't have a complete scan here, basically if you had the time, you would just keep trying again until you get the scan data you want and until you get something you're satisfied with. But I'll just show you these functions just for the sake of learning what they do. So the first one is Solidify, and what that'll do is it will just sort of do some quick calculations and try to make the most simplistic solidification there is. So if you have almost complete scan data, just like little holes here or there, it'll be pretty accurate and close it off. This is probably going to do something crazy because it's like mostly gone. But we'll see. We'll see what happens.
It just interpolates the data?
Basically, yeah. So you see here we have this side which looks okay, and then this side which does not, because that's the side we didn't finish. But some other features we have. Yeah, actually the data is not too bad for this side, but for this side it is really bad. So imagine we want to erase something, so we've got this erase button here, and it just sort of works as a wand, so you just kind of lasso in the stuff you want to erase, so that'll just kind of take a chunk out. And it does it straight back. Oh, I'm still in that. I didn't want to do that. Stop. Deselect, erase. So if I rotate this, you'll see that it actually just does straight back for erasing. It doesn't actually, do any special math. It just takes that chunk straight from where you're doing. There's also a crop function, which I don't use much, but it basically just crops the same way a picture does. It'll just keep whatever is inside that box once it operates. Oh, it didn't do it. Never mind. So we got the crop there. You can see this is the okay part of the scan. And it automatically moved on to the next step. So we have 3 different options here now. So these options deal more with the color. So auto enhance and touch up will both enhance the color of the scan. So that helps a lot if you are in a low light situation or just aren't getting the colors you want. You can always touch up and adjust the saturation or contrast of anything. There's also this trim, which I don't really understand it quite because of the erase and the crop function. There's not really much of a function for it. But if we go next here, our final page is save, upload, or print. It does have a default printing option. Personally, in our lab, we prefer to download it as an STL and then print the STL because it tries to use its in-house slicing software and all that. And just for our preference, we usually just save it as an STL, print that. But yeah, so this is the Sense. Are there any questions up to this point?
What is an STL?
Good question. So we cover that in our introduction to 3D printing class. An STL is a stereolithography file, and these are the files associated with 3D printing. So it's a .stl, and what that means is it's a large mapping of triangles, and that forms 3D shapes. And an important part to an STL is that there are no holes, there are no splits and no overlapping faces, and all the faces are pointing outwards. And so that's what functions like Solidify do. It makes sure that STL is ready to print and won't have any issues just sort of with the computer trying to interpolate that data.
So it's a coherent map, like a 3-dimensional map.
Yep, and then a slicing software will take that and slice it into thin layers and assign G-code to each layer. So that's where printing or scanning comes into printing, but there are some steps in between, such as mesh editing or touching up the file that you have from scan, because scan data is not always perfect. But so yeah, that's a Sense. To summarize, it is less resolution than the VX scanner, which we are going to go over next, but it gives you color and it's really easy to use. So they have one available for rental in the library as well. If you just walk up and say, I'd like to rent the Sense, you can get a laptop and a Sense with that, scan a friend or whatever, and turn it back in, use it for free. So that's nice. So yeah, moving on to the VX scanner, which is over here. Might be a little harder for some of you to see the screen. Let's see what it can do here.
And you were saying that the Sense software actually does the printing as well?
Yeah, it can do its own slicing. We prefer not to use that though. We prefer to just take the STL, manage that file and then print it ourselves.
But in your house, you could actually hook that directly up to a lull spot.
I haven't tried it, but theoretically.
Okay.
All right, so for the next one, do you want to move the camera up at all? It might help if you come over here for this one. Yeah. So we'll have this here. Cool. Cool, cool. So you might want to watch out just a little bit this way. This one has lasers and UV and stuff that's not good for your eyes, but I won't point it directly at any of you. I'll wait for you, don't worry, take your time. So this is the second scanner we're going over, the VX scanner. So couple things to go over on this is the buttons. So the main button here is the trigger, and that is the scanning button. So this is what you'll use when you're actually attempting to scan. You can press it on and again, off again during a scan to sort of stop and get your bearings. There are two buttons here. One is preview, which I'll go into in a second, and the other one is resolution, which I usually advise not using, and I'll go into why that is. So this is the program for it, VX Elements, the program that goes with the scanner. This scanner is not available in the library, sadly. We just have it here in our lab and requires a lab pass to use. But once we get started here, starting the scan, I've got my little pedestal over here. So what this is these are all basically targeting markers for the scanner. This scanner doesn't have a way in the same way as the Sense, where that if you lose tracking and you put it back to somewhere similar, it'll track where it was. This one can't do that. This one solely relies on all of these tracking markers around. So it is probably a good idea to offset a lot of these. People walking by find it entertaining to line them all up, but that's not the best. So once I have some of these, I'm free to start scanning here. There's a lot of settings going along on this screen, but the main thing I'm going to do before the scan is this resolution. So it starts off at default 2 millimeters, but I'm going to go down to maybe 0.8 for now. So when I hit the start scan, it's going to ask me if I want to apply the changes, and I do. And now we're actually ready to scan. So it's important with this scanner that you keep it pointed away from other people's eyes. It deals with lasers and some infrared light and stuff that's really not good for your eyes. But the first thing that we're going to go over is that preview button I was talking about. So you can see barely on that brain on the pedestal, you can see a little X. And what that is that's actually the only place where it will start taking data. Once I pull the trigger, it's incredibly hard to see, but the red X is still actually on that brain right where it was. So that's where the preview button comes in handy, is that if I lose track of where that is, I can press it. I'll show you guys for your sake over here. And I'll turn it back towards the camera in a second, but you can actually see where the X is on the scan real time on the window. And the next thing is this bar right here, so you'll see it's blue, and as I move forward it turns green, and if I get too close it should turn red up there. And so what that lines up with is these right here. So use my preview button, find where I'm at. You can see it says I'm a little far back here, and as I move forward, it'll start giving me this front error. So this is actually the depth sensor as well. So turning this back over here. The next thing is the high resolution button. So you'll notice if I hit this, it sort of zooms in on there. And when it zooms in, it takes special data points, I guess, that are supposed to be higher resolution. But in my experience, they are not higher resolution at all. It just sort of turns out lumpy. But for the sake of this training session, I'm only going to scan half of this brain. I don't want to blind everybody in the room. So I can rotate this now. An important thing to note is that right there, after I've moved it, I never touched any of these location markers. Although they are vibrating, I can wait for that to be done with before I start scanning. If anything moves, including the part or any of these scanning targets during the scan, it will usually result in bad scan data and you'll have to start over. So it's really important that you try to leave this as still as possible. But the nice thing about this is no matter where you rotate it with all the targeting markers, it usually catches back onto where it was pretty quickly. So I've got most of it scanned here. So I'm gonna come here and go back to a couple more settings.
You just scanning the whole thing and making all the red dots turn white, is that the
So no, so what I'm doing here is if I pause this scan, the normal process for this scanner would be you can pause and play as many times as you want. It's not the same in the sense whereas it's basically one go, retry, or it works or it doesn't. For this one, you can pause and play as many times as you want. And as I said, trying to remain with all of this not moving. But basically what I would do if I were trying to get an actual scan data is I would zoom in here and basically tell myself, oh, I'm missing a little bit of the top, or oh, I'm missing the back. And then I'd play it again and come back and finish scanning those areas to try to get as complete as solid as I can. Here is the high resolution area that I recorded. So you can see it really does just sort of turn out lumpy. I'm not really sure why it does that, but I usually just stay away from the high resolution button. You can get up to 0.2 millimeter resolution already with the normal settings, so I don't think there's ever any reason to go above that. Does sort of turn out lumpy. So yeah, I'd basically keep going and keep scanning until it's as complete as possible. And so the next steps would be, first thing is remove isolated patches. There's a lot of editing stuff you can do here, which is really beneficial for the scan data. But I feel that another program, Meshmixer, which is one of my favorites, is really good for handling scan data because parametric CAD programs such as Creo or SolidWorks really can't handle scan data because there's so many faces facing so many directions. But Meshmixer actually edits it, and I'll go in that in a minute. But one thing Meshmixer struggles with is all these little patches. So you'll see there's little tiny patches from the scan data sort of left around as relics from the scan. And this remove isolated patches button is the last option on this list. And it usually works at about 60 to 70 will get all of them. You can see now there's no more of those hovering patches around, not excluding the targeting markers, but there's not actually scan data sort of hovering around anymore. Sort of just eliminates that white noise. So once I apply these changes, you can also optimize, decimate. For the sake of this, I actually might decimate it a little bit. Just to speed up the next part, I am going to show you a little bit of Meshmixer, just some of the basics. It's a really intuitive program where the more time spent using it, the easier it becomes. But for now, I'm just going to decimate the scan mesh because I'm not really that concerned with it. But I hit apply, and once it's done thinking, I'll have my dealio here. So I have this guy, and next thing what I'm gonna do is file, and it's actually not save session. With VX Elements, we almost never save the session because what that means is it's actually recording all of these location points. But as I said, we are a public lab, people walk by and move stuff. The chances of you coming back to the exact same configuration is almost none. So what we do is almost every time we export the mesh, and basically that's gonna give us our STL file. So once we save it as our STL, and binary, by the way, it'll layers ASCII and binary STL files. Binary are usually better for scan data. For large files, it results in a smaller file size. So binary is usually the way to go for that. And save that. Cool. So, any questions about this scanner or this step of the process?
Do we have to kind of conform that we can't scan the bottom of that object?
Oh, great question. So, that's an interesting thing about this scanner is that many times you aren't able to get the bottom. Some things I've seen people do, for instance, something like this. Put that in my hand. What people would do is sort of put something like this upside down underneath, and then use that so that they can sort of get, underneath, because with this, the easiest way to sort of get around is the lasers actually come out of this portion. So an easy way to get underneath stuff is if you actually hold it sideways, you can get underneath, because if you hold it like this, you're actually kind of clipping the edge here. So it is easier to get underneath the edge with the scanner like this. Another thing I've done in the past is I've also used some of these guys. So for instance, something like this, I can put this in the middle and prop this up against it, so that now that portion that I'm missing is much, much smaller, as opposed to the entire bottom of the brain.
So you can just interpolate that little bit.
As opposed to the entire bottom, yeah. So it is one of the shortcomings of, having to leave everything as it is while you're scanning, but there are ways to get around it. It's just sort of clever. I've also seen people hang, one of the projects we get in here a lot is a veterinary grad student who is scanning bones and printing them. And so I've seen her like hang teeth up here and stuff, like up top, so that she doesn't actually have to worry.
Or
Yeah.
you could use like a stick with some clay and just have like a little
Yep.
bit that-
That's one of the good things about this, is you can get creative. There are shortcomings, but you can get around them. Any other questions about this step? Cool. So after we're done with VX Elements, we're going to take this, and it will ask you if you want to save the session. I almost never save it because of the targeting markers, but have my handy dandy Meshmixer open here. Move this forward for you guys. So open only works for Meshmixer files, so we're always going to go import. So then if I go into my documents, VX Elements projects, half brain, open that guy, we'll see that mesh I just produced. Yeah, it might be easier. I'm going to cater to the camera a little bit. So Meshmixer, you'll see this half brain that we just got. And it'll label the inside as this red and white line, and that's where I referred to the faces having to face outwards. So Meshmixer will actually label which is which. The main thing I use this program for is solidifying. So whereas the Sense had its own way to interpolate that, it always comes out weird. It gives preferential treatment to certain dimensions over other dimensions, so it seems like something comes out lopsided. But with Meshmixer, it's really just really good at like accurately guessing what the actual shape of the object is. So you'll go to Edit and Make Solid, and what that'll do is it'll think through here. It's going to think for a while about this massive hole I have because it is large. But the less holes you have, the faster it'll go. So you can see pretty much everything outside of that giant hole where it had no data, pretty much everywhere else it was able to, think about what it wanted to do. Another thing you'll notice if I zoom in, not that far, is that I've lost a little bit of quality as well. And that's because the solid type is always set to fast by default, which means it'll do a fast assumption so that your computer's not working forever. If you really want accurate data from this, especially because it gets down to 0.2 millimeter resolution, you'll switch this to accurate. There's also a solid accuracy and mesh density. Both of these sliders work in the same way. So if you switch it to accurate and slide both those sliders to the max, you'll basically retain all of your resolution. And so that allows you a little bit of freedom for if you want a faster process for editing, or if you want more detail afterwards, sort of like whatever your preference is. For this, I'm just going to leave it at a really low resolution, just so we're not waiting around for the program to think while I'm going through this. So I'll accept that. What it'll do is it actually keep the old one as well. It'll keep the old shell and the new shell, so you don't have to worry if you do it. You can always go back. But what I'm going to do is click on that old one with the hole, and I'm just going to delete that with this bottom right button, leaving me with only the solid one. So the next thing you'll notice is there's sometimes stuff like this, which is sort of floating off in the middle of nowhere. And that's a result of the solid process within Meshmixer, as opposed to VX Elements. At that point, it was still connected, so VX Elements didn't remove it. So what I'll do for that, so if I go up to the Select tool, it'll give me this little brush here. It's a little too big. You can adjust your brush size. So what I'll do is I'll literally just select that little portion, rotate it around, make sure the back is selected as well. And then I'll go edit and discard, and it'll just get rid of that. Another thing that happens a lot are weird outcroppings like this one. So if I don't want this anymore, I can also go to that select tool and just select that. And another function it has, once I make sure I get the other side, it's better not to leave islands for this because it'll work less if you're not complete. But if you do edit, erase, and fill, it will actually fill in the hole after it removes stuff, so that's good for outcroppings. Another thing, major thing you might notice is, you know, how rough this looks because of how it anticipated it. So then for that, we've got the sculpting tool. There's a bunch of different brushes, you know, I'm gonna undo this one, but you can do crazy stuff if you have your strength turned up, you know, you can just do crazy extrusions. No sense for that though. What my favorite tool is the robust smooth, and so that'll just sort of make the most generalized average of everything, and the longer you hold it, the more it will process. So there's both a strength and a size button for this, so you can adjust, you know, low strength, so you kind of can be careful around details you still want, or you can do high strength, which I'm going to do for this, because this stuff usually takes a while otherwise. But you can see I can smooth out pretty much all of those.
So it's like a geometric smudge tool.
Yeah, basically. Also bringing it back to that VX elements. So I was talking about this area where I used the high resolution, but it sort of just turned out lumpy. For something like that, I would turn down the strength, and you can see I can kind of just take my time over it. And, you know, if it's taking too long, turn it up a little bit and come back. Just sort of take my time with it. One thing to keep in mind though is that you can lose features. So like for instance, this side of the brain, if I turn up the strength too high, I'll just lose all of the lobes. Nothing will be left. So it is something you have to be mindful of. But yeah, the sculpting tool has a lot of variety to it. And as a reminder, I'm just going into the basic stuff of Meshmixer that we use frequently for our scan data. But there are a lot of other options you can play around with and learn how to use. Another thing that I'm gonna go tell you about is the plane cut. So plane cut's really useful. It's pretty intuitive too about coloring in the cross section and everything so that you know what you're doing. This is useful for 3D printing if you have a part that's too big. We actually scanned an elephant head that was too big for the client to print on one printer. So we use this, and it gives you two options: either cut, discard half, or slice, keep both. And so if you slice, you can actually keep both and save them as different STLs. And so what that means is you have two perfectly mating STLs. So then if you were to print them, you know that you could glue them together and they would have the same cross section that you're attaching to. So that's really useful in this program as well. You can duplicate stuff, mirror stuff, you know, basic stuff like that. But the final thing I'm going to show you about Meshmixer is the actual mesh mix function. And so this is something people ask about a lot, and it's sort of if you want a negative of something. So I'm going to drag this cube out here, figure out where it put it, because it's usually in a weird place. And I have to get this back to my brain. So as I move this around, just trying to get it to my brain here. So I've got this sort of on where I want. I can keep rotating, put it on. So weird thing about this program is you actually shift click to select multiple things. And I hope I remember to do this the right way, because with the two objects now that are overlapping, if I click one and shift click the other, I can do Boolean processes. So I can do union and make it one part, and it will just sort of look like this from the outside. But the main thing people want, there's also intersection, so I could just have the two parts that are together right now, and that's all that would show up. But the main thing people like about this is the Boolean difference. So if I click that, it matters which one you click first as to which it will subtract from which. but I hope it did it the right way here. Selecting brain first. Nope, did not. So I'm going to deselect, click that cube first, then the brain, try a difference again. Hopefully it works this time. Yeah, there we go. So now we've got our Boolean difference there. So that can be used if you want to make a mold of a scan that you've done or something like that. So any questions about Meshmixer? Cool. Well, that's all I got for you guys. So if you have any other questions, feel free to stick around and I'll answer them for you.